All right, so we're going to do some graphing of rational functions. So the same with solving rational equations and graphing rational functions is you need to be thinking about your denominator. Your denominator can never be 0. So in that case, in this problem, would be when x equal to 4. So my domain is going to be all real numbers where x can never be allowed to be 4. So what happens here is that creates a vertical asymptote on my graph at x equals 4. All right, so it's going to be kind of like a dotted line on the graph where you will never touch. You will never touch this line x equals 4. All right, so, all right, and so that line isn't really there, but we kind of just do that to make it a little bit like obvious where my graph is not going to go. Then there's a horizontal asymptote. Well, the horizontal asymptote is what you're going to be thinking about when you look at the numerator and the denominator and you look at the powers of the x's. The numerator has a power of 1 with the 5x. The denominator has a power of 1. When the numerator and the denominator match degrees, then you're going to steal the numbers in front of those x's, and that's going to be your horizontal asymptote. So in our case, our horizontal asymptote is going to be 5 over 1, or just y equals 5. So there's going to be another line at y equals 5 that's going to shape our graph. Let's see if I can make that. Maybe move it down a little bit. All right, so there's my two asymptotes, x equals 4 and y equals 5. All right, so now holes. There are no holes on this graph because holes occur when you have something in the numerator, like say x minus 4 and x minus 4, and there's other things in the numerator and the denominator as well, and they cancel out. So there's nothing to cancel here, so there's no hole. An x-intercept. An x-intercept occurs when the y value is 0. So in a fraction, the y value is going to equal 0 when the numerator equals 0, because you'd have 0 over a number, and so I need the numerator to be 0. So I basically need 5x plus 2 to be 0. So take away 2, divide by 5, you get the fraction negative 2/5. So you're going to get negative 2/5 right here. Now, the y-intercept is very simple to find, and that's going to occur whenever the x value is 0. So x values are 0 in my problem, so that would mean that this would disappear and this would disappear. So I would get 0 plus 2 on top, so I'd get 2. 0 minus 4 on the bottom, negative 4. Well, 2 over negative 4, that's negative 1/2. So I'm going to mark those on my picture. On my picture, let's see, I have negative 2/5 and 0, so right about over here. Well, not so much. So negative 2/5 and 0, and then also 0, negative 1/2. Now after this, you would go to some place on the computer like Desmos.com, or you go in your graphing calculator and you would graph the rest of this function. And mine's not going to be perfect, but what's going to happen is the graph is going to end up looking like this and go towards your asymptotes, but not touching them. And then over here, the graph will be up in this little corner over there, and it goes towards the asymptotes but doesn't touch them in this case. All right, so for this next one, this next problem has some factoring to be done before we can see everything. Oh, wait, I forgot some answers over here. Sorry, the end behavior. So the end behavior of a rational function has to do with this horizontal asymptote right here. It used to be that our problems would go up to infinity or down to negative infinity at the ends, but in this case, you see how this graph, this blue curve, is going towards the number 5. Well, that's because that's what the horizontal asymptote is. And over here on the right, this is coming down towards 5. They level off to the horizontal asymptote. So both end behaviors are 5, the horizontal asymptote. So technically, you can fill that in kind of at the beginning of the problem. All right, so in this problem here, like I said, we have to factor. Take a 2 out, which will leave me x minus 2. in the denominator, this factors into x plus 3 and x minus 2. So notice I have some cancellation. So when x equals 2, that's going to be a whole. So there's a whole at x equals 2 because that's the number when that thing would be 0. So this problem turns into 2 over x plus 3. All right. So my domain is still all real numbers where x cannot be 2 because that's the whole, and then also x cannot be negative 3. So even though this canceled, it was there to begin with, so you still have to use both numbers for your domain issues. But since the 2 went on to become a whole, that means the vertical asymptote that's left is x equals negative 3. Now, this horizontal asymptote has a different rule here. Do you notice the degree in the numerator is a degree 1 because x are the first, and here is a degree 2. When the numerator degree is smaller than the denominator degree, that means your asymptote is automatically y equals 0 for your horizontal asymptote. All right, so let's get a couple of these things drawn in. So y equals 0 is going to be my horizontal asymptote. So right there. And x equals negative 3 is going to be my vertical asymptote. So remember, these are going to shape your graph. And then let's go ahead and find some x and y intercepts. So the x-intercept is when the numerator equals 0. So you see after my cancellation, my numerator is 2. 2 doesn't equal 0. So there is not going to be an x-intercept. But the y-intercept is when the x's are 0. So if this x becomes 0 right here, I would get 2 over 3, so that'd be 2/3. So I'm going to mark that 0 and 2/3. Okay, we're about there. All right, my end behavior. Remember I told you in the last problem, the end behavior basically matches your horizontal asymptote, so it's going to be 0 in this case. All right, so my graph, if you go to Desmos or go in your graphing calculator, you're going to see it come across here. And it'd be a little lower. I was off my intercept there. And then it's going to be over on this side. Okay. All right, one last question you might run into is this. Which of the following describes the end behavior of this function? So you know that that's just the horizontal asymptote. So take a look right here. Those x squareds, they match. So what you're going to do, the horizontal asymptote, you're going to steal the numbers in front. 8 over 4. I'm sorry, 8 over 2. So 8 over 2 is 4. So there you go. Now every once in a while you might get a picture with 2 asymptotes. So that's no big deal. You know, a lot of times you get a picture, and if you have 2 asymptotes, you know, let's say you have one at like -3 and another asymptote at +1 or something, and then you have a horizontal asymptote at y equals 1. All right, so it's no big deal. Just realize that something has to happen in every section. Something has to happen to the left of this first asymptote, in between the 2 asymptotes, and to the right. So oftentimes you'll get a picture, maybe looking something like this. Like this one might come across here in the center. Maybe it comes through and goes like that, and then over here on the right it goes like that. So don't worry if your graphs are kind of complicated like this. It just, you know, every situation makes a different graph. And that's it. Bye-bye.